Thank you to the Pennsylvania Soybean Board for sponsoring our 2025 Crops Conference and Crops Days events. The Pennsylvania Soybean Board is responsible for the proper allocation of soybean checkoff dollars. This farmer-led board preserves and advances animal agriculture, identifies and promotes sustainable practices that provide ROI to farmers, promote biofuels through partnering opportunities, and drive new initiatives to increase the value and understanding of soy. Check them out online at pasoybean.org. Sponsors like the Pennsylvania Soybean Board allow us to host the annual Crops Conference and Crops Days events across the state. These events recap the 2024 PA crop production season, give insight to the latest agronomic research, products, and technology, and offer attendees pesticide recertification credits. If you would like to learn more about these events or to register, visit extension.psu.edu/crops-2025.
I'm your host, Ryan Spellman, and I'm joined here with my co-host and colleague, Justin Brackenrich. Justin, are you ready for the second part of our two-part series today?
I couldn't be more excited to learn more about what's new and up and coming for the growing season in 2025.
That's right. We're always looking forward. That's our new motto for the year, 2025, always looking forward. So on this second part, again, just to review what we just learned here, we just heard from Dwight Lingenfelter on a weed management update for 2025 on a previous episode. So if you haven't listened to that, that came out earlier today, please take a listen to that. Now we're going to move on to some of the other difficulties or pests that we have in our agricultural fields, and that's insect pests and diseases. So we'll start with a 2025 agronomic disease update with Dr. Paul Esker. So Paul is a plant epidemiologist on our team, and he does a lot of work with fungicides, with white mold and tar spot. So we're going to get his perspective on what's new in this season. So Justin, anything to say before we bring him on?
I'm looking forward to it, and I always enjoy when we get to do podcasts with Paul. So, Paul, let's hear it.
Yeah, thanks, Ryan and Justin. So for this year, what we've done since we have a new agronomy guide available, we go through on that kind of biannual cycle. We update all our tables for corn, soybean, whether we're talking about foliar fungicides or seed treatments, as well as for wheat. So all those tables get updated. What I can tell you is it's not that we're adding a whole lot of compounds here. It's a little different from the herbicide world, but typically we fine tune the ratings, the relative efficacy for each of those compounds. So that's, I think, what most end users in Pennsylvania in the region will find. What I really want to emphasize with regards to those as well, on an annual basis, these always get updated through the network that is the crop protection network. So mostly Extension and other researchers across the US. So that's another way to access this information. Those are simple PDFs that you can download, print 1 to 2 pages, maybe 3 on the top end. And we use those a lot in our training. We use those extensively in our programming. Kind of, I've got a talk in a couple days. That's kind of the segue between the topics, if you think about it. Not that we go through the fine details, but we really try to use those depending on the crop and the need to assess what our primary areas we need to focus on. So soybean's a good example in which we look at it from the perspective of what's a foliar disease target timing wise versus, say, white mold target, which they don't align perfectly, and the compounds we have available are going to be somewhat different with regards to that. In a little bit, I'll mention one of the new compounds that we will be talking about throughout the winter that aligns to white mold in a bit more detail. But before that, I wanted to emphasize maybe the newest thing we have, and this is both for the agronomy guide and also through crop protection network, is we now have a fungicide efficacy table for alfalfa disease control. If the audience goes to look at this, what they're going to find is a lot of more question mark type information on there. The work on alfalfa diseases and looking at fungicides is not new. Actually, I think some of the first trials I would have done in a previous life, if you will, were probably late 2000s, '08, '09, '10, that period. Others have continued to that. We actually have spent the last couple of years doing these sort of trials, not just for alfalfa, but also for some forage grasses and in that respect. Even with that 15-year history, we just haven't made a lot of inroads. It's a tough system to work in because the foliar disease complex, everything. For those familiar with alfalfa, you'll see spots everywhere. And so the challenge is, do you look at overall disease? Do you try to identify these? This is a subject that takes me back a long time ago. There was a colleague in the lab I did my master's and PhD in, and at Iowa State, who actually did yield loss and remote sensing work using alfalfa as the model. That was a heap of work. I could use other terms, but we'll keep it civil. And because of the way you had to identify things and try to estimate the disease and the practicalities of that. And more importantly, the challenge with alfalfa, and this is why at least getting the table gets us push it in the right direction to try to fill in these gaps, is that post-harvest, all the quality parameters. There are things we look for, but again, the data are really variable. And this is a system, even from an experimental layout, what's a reasonable plot size? It's going to look very different from, say, corn, soybean, wheat, the plot scales we have to look at to really assess quality, getting the right parameterization of those factors involved. So it's new, but it's more as an initial guide because these are things that have an alfalfa on the label that we would want to emphasize there.
So, Paul, quick question on that. In alfalfa, a lot of these products, what major diseases are they really targeting?
Yeah, that's a good question. So I'm actually looking at the table right now, and in terms of our other tables, this could fit on a half sheet of paper. If you're looking, what's really on that efficacy table, we have the following diseases: anthracnose, common leaf spot, Leptospherulina leaf spot, spring black stem, stemphillium, summer black stem, yellow leaf blotch, and sclerotinia stem and root rot. So a lot of from a foliar and or foliar stem disease combination, a lot of things that we can draw parallels to our other crops. But the truth of the matter is really there's only, looking at this more closely, there's really only two diseases where there's enough data to start to give some relative ratings, and that's for common leaf spot and Leptospherulina, which are probably the most common, when you go out to look at alfalfa. And really at this point, that's very limited. And I'd take with a note of caution what means poor. It's just we haven't had enough. I really think it's with the trial types, we just haven't had enough environments to probably move the needle on some of these. Preaxor does tend to look a little bit like there's some efficacy there, but how do you translate it on the back end? I could say the same thing for corn ear rots. Other things, it's just a bit more variable right now. A lot of these are still, if you will, they're labeled, but they're not really known what the efficacy is because again, it goes back to how should we best assess this in the field and the efficiencies of doing that. So it's a really good question. I think I th- I'm hopeful. I'm hopeful a little bit with this that it'll push us in the right direction to improve some of the research opportunities again in alfalfa because it's still a really important crop. Here in Pennsylvania, we can draw parallels to other forage crops as well, where we've had a look, but it's the same sort of challenge. What are we assessing? How do we actually measure that quality component?
So one of the things I'm looking at the tables too while you're speaking, one of the things that I like about them, and again, they're online. We're going to add this to the show notes. They're also in the agronomy guide. But Paul mentioned that they have this NL is one of the denotions that you can find for not labeled. And I think one of the things that I have to do in extension a lot is to explain or remind people that just because something may work, or if someone else did it, or you have it in your building, doesn't always make it a legal or recommendable application, right? And so as we start to think about our diseases, something may be very good for one, and justifiably you could make the argument that it may be very good on something else. But if you don't have that legal application, and like we say at our meetings, the label is the law. You are breaking the law by making that application if it's not labeled, and your desire and your goal is to treat something like that, right? So I think that's great that that's also put in there.
I would agree. I mean, this reminds me of a story. I think when I first started in extension, and it happened to be a weed related question. I was at one of the first meetings I would have went to as an extension plant pathologist, audience 90, 100 people. And the, I don't remember the specifics, but more or less it was this. The extension weed scientist at the time was talking about a specific weed, and somebody in the audience raised their hand and said, "We've used such compound or such product." And everybody, yeah, you can see people's ears perk up, okay, and we've had good success. And the extension weed scientist at that moment, very calm demeanor about him, just kind of calmly says, "You do know that that weed is not on the label with that product." You could hear the audible gasp. Yeah. Like the light bulb flickered. Oh, we do have to pay attention because it is very easy. And we you often get that question for new diseases, for new weed species or other things, resistance management. And you really have to we always reiterate the law. The label is the law, and you need to look at that closely. And you have to wonder, I think the companies are looking at it from various factors or examples of what they're aiming for. Like the couple you reference, if you look more closely at it, you can tell, where we say not labeled for use against this disease on the alfalfa table versus labeled but unknown efficacy. That is really critical. That means the company behind that product or that compound is potentially at first trying to target what they deem to be the most important diseases, where what is it in the background of that product, what is it attacking, and why does it align to certain fungi. Not all fungi are the same in our world, and that's a really important point. There's also other factors: marketing, likely return on the investment. Those are things you got to think about as always, because not every company is going to see a cost benefit to trying to promote it against everything. And it's the same thing, alfalfa. For those who are interested, there's questions about, is it first cutting, second cutting? Where does it fit in that on top of it? So even there's a series of sub questions that need to be explored. So you have to have a good understanding of when do those disease kind of bloom, when do they come out relative to those cuttings cycles. How many cuttings are you aiming for? Where do you put your best bang for your buck? And then ultimately the weather is going to drive a lot of that.
Yeah, I'm excited at this direction. I know as a plant pathologist myself, it's one thing that gets overlooked is looking at forage diseases and management. And I'm sure Justin's excited to possibly have some more options there as well, being a forage guy. So you're hitting all the hot topics for us at least. So I guess let's move on then, and talk a little bit about. I know you mentioned that there might be some new fungicides and maybe other things we've learned about white mold. I know I've had a trial with you guys in my counties, and we've had a few trials across the state.
Mm-hmm.
Anything new learned about white mold in soybeans or management?
Yeah, we're taking a couple of approaches. One is we have funding looking at the drone technology there in that system. We're supported by a couple sources northeast there, as well as the Pennsylvania Soybean Board. But within that, we've also been testing now, and we use an on-farm model because of what we know about the disease, where we can find it. But we've been testing Viatude omnira, which is from Corteva, over the last year or so. And so that's an interesting one because it's a group 3, group 11. So it's got the combination of strobilurin and triazole. in the mix. So it's got picoxystrobin and prothioconazole. If you look at the chart for soybean, you can actually match up where kind of the base products would come from. Uh, and that's important because there's always questions about timing for white mold management. You know, do you hit it when the flowers are first coming out? From a protective perspective, do you get any sort of longer term residual in there? And I think there's debate. Do we wait a little bit to start spraying if the year is favorable? We see some different things in our data this year in particular. It seemed like a little later, maybe it was a little more efficacious, but that was also a function of the planting date, you know, kind of when do the crops align. So we've been testing it. We did have it in our work, in some of our drone work. We see it performing comparable to the Laro Complete approach. So we think it'll offer another option there. Maybe one of the potential other benefits is it probably has some foliar disease cleanup, although we don't see a lot of foliar disease issues. Or we haven't seen it to the level of where we're noticing an effect of spraying fungicides at R3. So again, that timing issue, just since I'd say the last year we had really significant results was 2019. But from a white mold perspective in our environments, like where you are, Ryan, you know, you get into some of those microclimate, you get out, we know we have pockets. I think this gives us something else to look at in the equation that way. And the limitations of using it aren't unmanageable. I mean, the rates are within range and the number of potential overall sprays are out there, but meaning maximum number of sprays I think are 3, but it's highly unlikely we would get to that level in our systems to need that. Probably where we have to dial it in, and we had these same conversations a couple of years ago with some other compound. Do you delay it? Do you hit it R2? You know, kind of full flowering to early pod. These are the sort of questions I think we wrestle with. That's also a function of trying to work with farmers who, what is actually early flowering, what is full flowering, all of these sort of questions that way. So it looks promising. We didn't have the greatest severity this year, but we had enough to at least evaluate it and do some good comparisons that way.
So one of the things we talked about before we got started here, well, actually multiple things, but we talked about your work with the white mold. We talked about how you're improving management there. You're improving some management options within tar spot. And before we jump to those, you talked about using this open crop manager as your scouting tool. Is open crop manager, we'll let you explain that a little more. Is that being used in this white mold or these tar spot management decisions? Can other farmers get involved in that? Is this something like, because you're talking about maybe we don't see the leaf disease, maybe we do see the leaf disease, what spraying application and timing is it happening? I feel like that's a huge data set that Open Crop Manager can really help us get to better.
Yeah, on the soybean side, so we've been testing, and you've both been participants in this kind of area with us. We've been testing this scouting tool. We have over 100 abiotic and biotic issues that we can evaluate in the field. We can capture the field settings. We follow up with the production surveys to add that layer. For a farmer, what we've seen when we talk to farmers about the value is you're getting eyes on the ground again that we can use for other modeling exercises or other approaches to improving effective scouting. The value this year in particular, this past year in particular, the value of that information that we're putting out there when we've met with farmer groups is they see something I really feel they haven't seen. You know, we lay it out over space and time, where you are, how much are we seeing. I have a slide I use in the winter meetings. I kind of indicate by disease what we're seeing. You know, would a fungicide be targeting this? Would the timing be similar or different if we, you know, kind of breaking it apart, or would it be some other management tactic you have to apply? It helps us have this conversation, but I think more importantly for the farmer or the crop consultant, it allows them to really add a layer I think they've been collecting, but maybe with some of the digital data driven type tools we can bring to the table with it, something that they haven't had before, just to help them confirm, yes, this is what I'm seeing, this is not what I'm seeing. In the last 2 years, we've had, I think, unique reports, which are field locations, so they're cross field, almost 4,000 of those from Pennsylvania. So it's a rich data set. It's freely available to anybody who would like to contribute. We'll be offering training this winter for that as well.
And like you mentioned, that's a product that we've been using in extension is extension agronomists. We've used with our interns. We've had discussion. The thing that I think is the utility, before we jump to tar spot, right, is the last kind of thoughts that we have with Dr. Esker. The utility that I like about it and the approach that I see as being very useful for a farmer is you can pull this up and you can see your reports from multiple years in the same field, right? And so sometimes when we're making management decisions, we go out and we think about like what's going on or what's happening here, and we think, well, I'd look at that when I get back to the house and I see my records. Do we? Right? That thought's kind of out of our head, or we have to go home, we have to dig the book out. Most of us are never more than much more of an arm's reach away from our cell phone. And that information is now there that I can go back and I can look at the scouting reports that I've put in for these fields over the last few years. And if I'm talking with this producer about field 6B, I can say, well, down here in this low spot, we did see XYZ, right? And that's something we should keep an eye on. And I think that's not only useful to the crop scouts, but the farmers that are doing it themselves.
Exactly. No, I would agree. I liken it. So my training, if you look at my age and my training, kind of my predecessors at that level, it was always like the kind of that twitchy, itchy elbow syndrome. They could sense a year and they would catalog through their observations, their mental observations over time to kind of link that up to an issue. One of the things I think I'm excited by working with John Wallace on that side, on the weed management side, is being able to integrate that tool in. There's interest there in looking at, can we use Open Crop Manager to collect early images of weeds, kind of just as they're popping out, because that's the type of information he needs or the weed science community needs if they're talking about herbicide escapes, potential resistance issues. Kind of building the tool is one thing. Now making it even more practical, more usable for others is kind of a long-term goal. And I think this is the sort of thing, like you say, you can go back and start to channel those records and say, or with a little bit of spatial component there, where did you scout? Maybe you realize, hey, something occurred here when we were running across the field. There are a lot of things you can start to build. The simple take-home message I use is, we always say, know what you should know. So when you see something you don't know, that's when you bring in the educators. That's when you bring in the specialists in those areas. But that tool helps you, I think, get to that level.
All right, great. Well, I think again that tool is really helpful, and it would be great to get to the point, and I think we're moving towards this point where it's going to be really relevant for farmers to use themselves as well, and pull a lot of data that we've all been collecting for a few years now. So I guess before we close out here, I want to just touch on one more thing. So maybe if we don't have a lot of time, but if you could give us maybe a few highlights of what you see coming up for tar spot. What have we learned in the last year or so that will help folks with tar spot management? Any new products, things like that. Just a highlight.
From a product perspective, things kind of are where they are. But I think the big take home point, and this, I'll let you can come back and ask me how it went. I'll be testing this out on Thursday at one of the meetings. We noticed this year, and this is very important, I think, as much for our Pennsylvania audience, maybe as for others. We were able, even with some of the droughtier conditions, we were able to pull apart for the first time, I think, the clearest example for us where we would see the onset of gray leaf spot and efficacy maybe anywhere from V12 to VT, VTR1 in that arena, so 12th leaf to tasseling and into early silking, kind of show good response, where tar spot is really at that tasseling out to about R3 into milk and into some of these other growth stages. But the key point is if I draw a circle over VTR1, I can kind of overlay the two, I think, in likely response. That gives us a nice place to start the conversation for our management, and it aligns with other observation. And that's probably where we're going to be emphasizing a lot of this conversation. We see it in terms of potential yield response, as well as what I think would be the back end economics in situations where it's warranted.
Well, that's I think a great little teaser for folks to come to some of our pesticide programming if we are in your area, and Paul will be there. I know for tar spot, one of the questions the last few years has been, we're not exactly sure what the timing is. We think it's at tassel, but to actually see an overlap of managing gray leaf spot, tar spot at VTR1, I think that's a really useful thing to give folks to hook onto, and also say, as I've been doing tar spot programming, a lot of times I'll say, you want to manage it like you would manage your leaf spots, without really knowing, is that the case? I don't know. And then people question you a little more, and you say, well, there's this caveat, that caveat. So I think that's a great thing to see, and a hopeful management step that we can use in 2025. So that I'd say, thanks, Paul, for coming on. We'll definitely have to have you on again. Maybe we can do a longer episode on tar spot or disease management this spring.
No, sounds very good.
And
Thanks,
I have
guys.
the links for all of your efficacy table from the Crop Protection Network that I'll add to our link. So if anyone has questions or wants to follow up with those, Paul's pretty available. So reach out, and he'd be happy to talk to you about it.
Excellent. Thanks, guys.
Thank you.
All right, so we're going to get started with our next guest, who is Dr. John Tooker. He's been with us quite a few times in the past, talking about insects and slugs and all things related to them. But today we're going to focus on kind of what's new or what's up and coming, or what he's been working on and what he sees coming in the future of 2025. So, John, let's start with BT traits. What's going on there?
Great. Well, as folks probably remember, most corn hybrids grown in the U.S. for field corn, so grain or silage, have BT traits in them, and that BT stands for Bacillus thuringiensis, which is a soil bacterium from which various genes have been isolated that are toxic against insects. So folks use BT traits against above ground pests like European corn borer, fall armyworm, corn earworm a little bit, and the like. And there's others. But then if you're a farmer growing continuous corn, you're probably familiar with the BT traits targeting Western corn rootworm larvae, commonly known as rootworms. And so there are 4 or 5 of those that have been on the market for a long time. But one thing I wanted to talk about today was the new trait that is now on the market. And this thing is called DV-SNF7. And you can spell that DVSNF7, but everyone just calls it DV-SNF7. And this is a new type of trait. It was generated using RNA interference technology. And RNA is in every cell in a living organism, and it is what codes for proteins. We don't need to get too lost in the biology, but just suffice it to say that it's a new trait. And it's more broadly available in 2025. It was out there in some fields, mostly in the Midwest in 2024, but it's more widely available in 2025. And I know growers that have suffered from rootworms are thinking about using it. So Justin, I just thought I would provide a little bit of guidance on where it will have value, how it's being deployed, and some things to keep in mind. Does that sound okay with you?
Hey, that sounds fantastic. I actually have my handy corn BT trait pulled up beside of me. We're going to add that to the show notes. So if you need to reference any of that at any point in time, by all means, please do.
Okay, yeah, that's a great resource. It's an online resource developed each year and updated each year by an entomologist named Christina DeFonso at Michigan State University, and it's hosted on a Texas A&M website. But it's called the Handy BT Trait Table, and it kind of cuts through the alphabet soup that is kind of BT traits and their abbreviations and the proteins behind them. Okay, but let me get into it. So DV-SNF7 is available in 2025 in kind of two types of hybrids. One is something called the SmartStax Pro hybrids, and then there's a set of products called the Vorseed products. And that package includes 3 traits. So it includes this new one, this DV-SNF7, but it also includes what's typically been in SmartStax. And so those genes or traits are called the Cry3BB1 protein and the Cry3435 protein. So those 2 below ground traits targeting rootworms have been in SmartStax since they were introduced, a good number of years ago. So just 2 traits, both targeting rootworms. And the idea is if you have more than one trait, if the pest species evolves resistance to one, then you have a backup one there to still take it out. So kind of 2 modes of action being deployed. This SmartStax Pro or Vorseed, those hybrids, if they have traits targeting rootworms, again, below ground, you have the same 2 traits that have historically been in SmartStax, so Cry3BB1 and Cry3435, and then you have this additional one, this new one, with this new technology called DV-SNF7, okay? And a lot of folks have seen this new trait on the market as kind of a savior because they've been struggling, perhaps they've been struggling with SmartStax and rootworms are kind of eating through those roots just fine, and now if they deploy DV-SNF7, their problems will be solved. But this is the voice of caution that I wanted to raise, because research in lab settings has shown that DV-SNF7 can fail in as few as 3 generations. So this is not a bulletproof trait, just like the other traits targeting rootworms have not been bulletproof. So if one is to deploy SmartStax Pro or Vorseed, where they have been using SmartStax, they are likely to set themselves up for a challenge. And that's because if rootworms are resistant to SmartStax, that means they're resistant to the Cry3BB1 protein and the Cry3435 protein. And then only the DV-SNF7 is there to hold rootworms back. And because we know that this trait can fail in as few as 3 generations, if farmers deploy this, deploy SmartStax Pro or Vorseed, without consideration of it potentially failing, then it's likely to fail more quickly, okay? So once DV-SNF7 is compromised, there are no other traits to use. So I'm trying to encourage growers that are growing continuous corn to be careful with that trait, to shepherd it wisely, okay? So come up with another plan that doesn't require you to put SmartStax Pro on all your acres, so all those rootworm larvae won't be exposed to it, and maybe you can come up, maybe together we can help it last longer, because DV-SNF7 is likely to fail if it gets all that pressure for, say, 3 years in a row. So what does
for
that
the rest
mean?
of us that aren't entomologists,
Yes.
if I'm looking at, I don't know who those people would be. It's certainly not me, but I'm just trying to help those people out.
Yep.
If I'm targeting something like corn earworm specifically, let's just say that. What is 3 generations? Is that 3 years? Is that a shorter period than that? Can it be shorter?
Well, good question.
Okay.
So for rootworms, there's 1 generation per year. So that's 3 years or 3 growing seasons. For corn earworm, there's more than 1 generation per year. So you might get 3 or 4 generations per year, depending on where you are in the world. In Pennsylvania, at least 2, if not 3. So when I say generations for rootworms, that's growing seasons. Now, in a perfect world, farmers wouldn't grow corn continuously in the same field year after year. The best way to control Western corn rootworm is to rotate your corn with soybeans or sorghum or alfalfa or something else. Growing corn in rotation with rye that you take off for rylage is not a rotation really when it comes to rootworm, because you're still planting corn about the same time and it'll be in the field every summer. So the best way to control rootworm is to rotate with something else. And again, I just listed those 3 crops as examples. But if you're growing continuous corn, you need this. You need the traits. But the traits are kind of being overly depended on, and they're being used year after year, which is why this resistance has evolved. And it's evolved in Pennsylvania. It's evolved in the Midwest. And if we have no more traits, then farmers are going to be in a tough spot. So I've worked with local growers in central Pennsylvania recently to try to help them come up with creative ways of doing this. So some growers have elected to try to find a high yielding. So the growers I've dealt with are trying to carve up their acreage and have different solutions on different percentages of the ground. Like 33%, they're going to rotate the soybeans. Another 33%, they're going to use this Smart Stacks Pro in the first year because that will only provide, a moderate amount of pressure. And then the other 33%, they're going to try to put a non-traded a non-traded corn hybrid down and put insecticides in at planting. So to do that, they need to acquire an older planter that can use that can deploy granular insecticides. And you guys probably remember that back in the day, soil insecticides were the way to control Western corn rootworm. So everybody had planters that had insecticide boxes on them. When BT came around, there's less of a need for that. So a lot of growers have gotten rid of those planters. But I'm aware of folks that are looking to buy these planters that have that accommodate insecticide boxes just for this very reason of kind of managing this challenge in the long term. And so these local growers I've been dealing with, they're going to take those 1/3, 1/3, 1/3 solutions that they've developed and then kind of rotate through them over time. So no field is seeing the Smart Stacks Pro or Vorseed for more than 2 years. And you need to have some creativity and flexibility in mind. And when I went to talk to these local growers, their nutritionist was not interested in these alternatives. But I made it quite plain to them that if you don't do this, in 3 or 4 years, it could well be that you have no traits to hold back rootworm. So you're going to have to come up with a solution then. Why not implement a solution now that can provide a little bit of durability in those traits, kind of work with those traits and make them last longer. It may well be that other RNAi traits are in the pipeline. Typically, these things take a while to come to the marketplace. And I remember, it might have been 2013, 2014 when RNAi was first introduced as a way to control rootworms. It was kind of a small study that was published in a scientific journal. And we're like, oh, that's fantastic. Hopefully that'll come to market soon. It took about a decade, maybe a little bit less, to get that to market. So if folks are planning on new traits coming soon so they can just use Smart Stacks Pro or Vorseed blindly, I would think that's unlikely to happen quickly. I mean, the regulatory process happens a while. I haven't heard of any of these on the market, kind of in development. They could be out there, but it's still going to be a bit. So let's try to foster the best use of these products that we can.
I like to hear you not just talking about the trait, but then the caution of how to properly use that trait, because I think this is really important. So I just have one last question here about this. So let's say I have a big corn rootworm problem and I decide in this one part of my field, I'm going to rotate this year, right? Would you say that the next year you're not going to really have a rootworm problem at all, or that you might want to add this trait in to a rotation to really suppress it, right?
Good. That's a great clarifying question, Ryan. Yes. So if you rotate, let's imagine a 40-acre field, and it's been in continuous corn the last, say, decade or so, and you wrote that to soybeans or sorghum or alfalfa, just 1 year of that other crop is going to eliminate the pest population in that field, the rootworm population in that field. So let's just focus on soybeans. The reason that it works so well is because rootworm larvae cannot survive on soybean roots. So if you've been in corn the last 10 years, beetles emerge from being larvae, they mate and lay eggs, and they're not prone to disperse. So they lay their eggs right there. So when you move that field to soybeans, those eggs that were laid in that field last year when it was corn will then hatch into this current field, which is now planted to soybeans, they will try to feed on those roots, because those soybeans roots, but they'll fail and they'll all die. So soybeans acts like an eraser, more or less, in that field. So if you can move that eraser to every field kind of over time with some type of strategy in mind, you will erase the population. These pests, rootworms, are fostered by continuous corn production. So if you can break that cycle, you will eliminate the population. That's the goal of pest management, is to help, is to use their life cycles against them in a way, right? So to understand their life cycle and do something that disrupts it.
Well, I think that is a perfect segue in disrupting life cycles and understanding life cycles for us to bring up slugs. So one of the things that at least me and Justin are well aware of is some of your efforts over the last few years to monitor slug populations across the state and provide some more management opportunities. So well, you want to give us a quick, an update of what you foresee slug management to look like in 2025? What have we learned over the last year, etc.?
Yeah, I'm happy to. I will add before I get started that it is difficult to predict the future. I mean, weathermen try to do it every day, and most of the time they're right. But when they get it wrong, we're kind of critical about it. But let's just be aware that the future is difficult to predict. I mean, I'm pretty sure I'll go to sleep tonight, but what time is kind of unclear, so I don't know that. But let me recap the slug challenge we had in 2024 to provide some context. So I imagine a lot of folks who might listen to the podcast were aware that 2024 was a rough slug year. In fact, it was the worst slug year that I've ever seen. And I've been on the job since 2008, which isn't forever, but a lot of growers I talked to more or less said the same thing. And there are three main factors why slugs were so bad in the spring of 2024. The first is that the winter preceding the spring of 2024 was extremely mild. In most parts of Pennsylvania, there were very few months that where the average was below freezing temperatures. So the month of December 2023, at least in central Pennsylvania, averaged like 31 degrees Fahrenheit or something like that. But for January, February, and March, the average temperature was well above freezing. So it just never got cold enough. And typically during the slug life cycle, and the main slug we worry about in Pennsylvania is a species called the gray garden slug. The gray garden slug tends to have one generation per year, and in the fall, after they lay most of their eggs, typically they're killed by cold winter temperatures. But in 2023 to 24, the temperatures really didn't get cold enough to kill very many slugs. It more or less probably just killed the wimpy ones that were stressed out for some other reason. So that mild winter had allowed more adult slugs to survive the winter. And then when the warmer temperatures came in the spring, it was there was kind of more slugs than usual, and those adult slugs started to feed again, and then they started laying eggs again. So there was kind of two batches of eggs going into the spring. So there's kind of more slugs when we get to the spring of 2024, and then the conditions that we experienced, and growers will probably remember this, were pretty mild and they were pretty wet, and that just makes slugs happier. So that's kind of one reason. Was the mild winter. The second reason was the kind of good conditions for slugs in spring 2024. And then the third reason that slugs were so challenging is that so many growers planted their soybeans early. Now, a decade ago, it was pretty standard for growers to plant their corn. Once they got their corn out of the way, they planted their soybeans, and typically soybeans wouldn't be planted until the second half of May or something like that. But there's been some agronomic research that came out in the last, 7 to 10 years, I can't remember the exact time frame, that said that the longer the growing season your soybeans have, the better the yield's going to be. So that research in the Midwest is kind of agronomically based, and it makes good sense. So a lot of farmers in Pennsylvania have picked up that practice. So now typically they're planting their soybeans first. But that works if slugs aren't around. So that research in the Midwest wasn't conducted in the presence of slugs. And if you plant soybeans kind of too early in Pennsylvania and other mid-Atlantic state, and then the temperatures don't allow the crops to just jump out of the ground and grow like crazy, then slugs have the upper hand. So that's what we had. So we had more slugs than usual in good conditions for slugs, and people planted early. Those plants germinated, came out of the ground slowly, and were kind of sitting ducks for slugs. So that kind of explains the three-part reason why slugs were so happy in 2025, and one more in 2024, and one more detail that to bring up is those overwintering slugs, the ones that made it through to the spring of 2025 as adults and then started laying eggs again. They provided kind of two batches of slugs. So the soybean plants that were planted really early were probably being hit by that first batch of spring hatching eggs that overwintered, so overwintering eggs, and then later planted soybeans were really hit by that second batch of laid eggs that were laid in the spring. So the window during which slugs were hammering soybeans was pretty wide, from anywhere from April until early June. So to answer your question, Ryan, in a long-winded way, so for 2025, our slug experience is going to depend a lot on abiotic conditions. So that's what's the weather been. Fortunately, a lot of Pennsylvania is seeing a lot of cold weather. I mean, when I got in my car this morning, it was 15 degrees, and that's only a good thing for slug control. So if this kind of cold, if the cold spell continues, that's going to knock back slug populations, and we shouldn't have a repeat of 2024. But we'll have to wait and see. Like when it comes time to plant, I guess I would encourage growers to scout their fields and see what's going on out there. And if it looks like the long range forecast is kind of cool and wet, I would just continue to hold off on planting. My best advice for growing soybeans when slugs are around is wait for a good soil temperature. And you agronomy types can tell me the proper soil temperature for planting soybeans, because I can't remember. But once you hit that temperature, plant, and then those plants will get out of the ground quickly, and you'll kind of outrun the slugs. But so it looks like, from at least the cold winter perspective, that Mother Nature is cooperating and should knock back the slug population. So not as many adults will get through, and we should not have a repeat of 2024.
Great. Well, so, and as I'm sitting here, it's extremely cold here. Well, not extremely cold, but as it should be for the winter. We're seeing below freezing temperatures. So I'm hoping that this will continue to be the case, and the pressure is definitely reduced. And I guess if you're following along, the proper temperature is usually, I think of for planting soybeans, is you kind of don't want your nights regularly going below 50 degrees soil temperature. So you want to be above 50 degrees, at least as a rule of thumb.
John, I want to ask you a question. This might be kind of on the spot or devil's advocate, but what about snow, right? We talk about this cold temperature, we talk about the eggs, we talk about this stuff and the residue. I know where I'm at on the western side of the state, we've all got a pretty good amount of snowpack at this point. Um, is this a crystal ball question? Is this back to you? I'm going to go to bed at some point, just don't know when. How does that kind of factor into the equation?
Sure. Well, unfortunately, snow provides insulation for slugs. So the more snow that's on the ground, the better insulated they're going to be from cold temperatures. I mean, just think of an Eskimo living inside their igloo up at the North Pole with Santa Claus, right? Isn't that the vision that we're supposed to have?
Yeah, I think that's exactly where they all live. Yeah.
That's exactly right. Yes, let's paint with a broad brush here. Right. So the best scenario for knocking back slug populations is a cold winter with no snow. So here in central Pennsylvania, we just have a thin coating of snow, and you can kind of, looking out my window at the lawn here on campus, you can kind of see sprigs of grass sticking through. So that amount of snow is not providing much insulation at all, and these cold weather stretches will knock back those slugs pretty well, I would think. But if you have 4 or 5 inches of snow on the ground for a long time, or upwards of a foot, or whatever you have out there, that's actually working against us a little bit. So let's hope maybe there's a warm spell that takes that snow away, and then it gets super cold again. So those slugs are subject to the temperatures that we're experiencing in the air.
So it's kind of one of these, we'll say darned if you do and darned if you don't type situations, because agronomically we think the snowpack might help our alfalfa and our winter planted small grains and things like that to have a little bit more, just like you said, that insulation and that survivability, because that no snow, cold temperatures is kind of not what we want for those, but that's going to help us with the slugs in our fields that we'd be going back to in row crops. So, with everything in agriculture, there's push and pull and give and take, right?
Yep. Yeah, so there's a trade-off, but fortunately, we can't control any of it. So you just sit back and you look for the silver lining. And if it's really cold and there's not much snow on the ground, at least you can be comforted that your slugs are being knocked back. But if it's really cold and there's a lot of snow on the ground, it's like, well, at least my alfalfa and small grains are being protected. So just take the good where you can find it, I guess.
Yeah, so I guess I'm just going to get into the weeds just very quickly before we close out here. When we talk about, you mentioned that the cold temperatures will kill off adult populations. Is there a reduced hatch rate of like the eggs? Or do we know that at a certain level of cold as well?
Yeah, there is not. So, eggs are these resilient little packets, and evolution encouraged animals to have eggs for a good reason. Insects, slugs, birds, they're very good at resisting abiotic conditions. So, there's not a whole lot you can do. It's even been shown by a few researchers that fall management of say, or attempts to manage fall laid eggs by either turning over the ground or a turbo till in the fall or something like that is kind of ineffective against those fall populations. So there's not much to do. You can use the fall egg populations to kind of assess maybe how big the populations of slugs might be in the spring, but because of this wintertime mortality thing, it's kind of a waste of time, and I encourage growers not to do it. Fortunately, we're in January now, and no one's going to be doing that retrospectively. So we're going to have to work together to figure out what the slugs are doing in the spring. We'll be each scouting in our own areas, and we'll try to share that with growers as best we can. But my hope is that these colder temperatures have set us up for a better situation than we had last year at this time.
Well, that is my hope as well. And I will say, if you're going to go out and try to count eggs, I wouldn't recommend it because they're also very hard to find. So,
right. But if you had relatives that you wanted to, get them out of the house and they're just annoying you, you could assign them that task and then, come back after you've counted 100 eggs.
well, that's a great point. And I mean, it sounds like you might have a little experience there.
I was never told that by my parents, but I have thought about telling my parents that. I wonder if they'd listen to me.
One of the fondest memories I have of this job is all the times I've been sitting beside the road on my hands and knees with my butt stuck up in the air, counting slugs or counting any kind of insect, and the cars go by and blow the horn at you, right? You're just locked in, counting and looking and trying to find these. They're not microscopic, but they're slightly larger than the size of a pinhead, and they're basically translucent. And so you're digging around out there in the dirt trying to find these things, and then out of nowhere you hear just a horn blow, and it really is quite startling, quite alarming. So if you see your agronomist out there, don't blow the horn at him and scare him.
Well, maybe that's a compliment. Like it's one of those like you're looking good today.
Maybe. Well,
Or
I also think, yeah, maybe I'm looking at this the wrong way. I appreciate you being a glass half full type of guy.
yeah, it's a compliment. They're saying you're doing well today. Yeah, it's good.
Well, John, we appreciate you joining us today and talking about BT and corn. I think it's always coming up as a question. I'm actually seeing more questions about the price of BT and the price of these traded things and people going to conventional corn, right? So I think this is a great conversation to have. Is if there's not a lot of value to them, what's the point in paying for them? And if we're going to continue to blow through them and they're not going to serve us well, we do need to come up with an alternative option.
Yeah, without question. I get calls every year about growers who just don't want to spend the money on some of these high cost
Yeah.
seeds. And and it certainly is the case that many growers use BT as a default. They're going to use it every year and they don't really scrutinize that expense. But particularly for our above ground BTs, if you don't have those pests around, there's no reason to deploy that, and you can get lower seed costs, and that will make your profits higher. For rootworms, it's a little more difficult because if you're growing continuous corn, they're very helpful. And if you don't have planters that can accommodate insecticide boxes, then you might be in a tough spot. But looking for these ways to save money by not spending money on high cost seeds is certainly a prudent thing. You probably do it around your household, so why wouldn't you do it around your farm?
Sure, and I think that's a potential win-win situation for folks, and something that I'm hopeful for having more education for folks moving forward in that arena. So, well, thanks, John, for coming on again. And for our listeners, thank you for sticking around with us, and we'll catch you on another episode of the Agronomy Highlights podcast.